My name is Asim Ali Khan, working as a general manager in Addere Creations. I completed my masters in 2022 from RV College of Engineering in product design and manufacturing. In my RV College of Engineering master's degree, I had this project where I worked on the 3D printed cast. What is 3D printed cast? It involves three important technologies. Those are 3D scanning, 3D designing and 3D printing. All these three processes are involved in the complete manufacturing of a 3D printed cast. Now, what is a 3D printed cast? How many of you guys had fractures in your life? Once, at least once. Fracture, broken bone or hairline fracture somewhat. I think very less. Okay. So, while having fractures, you will be having that POP cast, which will be wrapped layer by layer. But sorry to say you that those POP cast will be having a lot of disadvantages. So, in order to overcome those disadvantages or overcome those limitations, we have come with a product called 3D printed cast, which is here, the green color and blue colored one. That I'll be slowly taking you through that product. How we achieved that, it will be totally personalized. Like if, for example, if I have manufactured a 3D printed cast for this person, that this person cannot use it because it will be totally depend on his unique anatomy of the hand. Okay. Now let us start how it is. First of all, let us start with our company. Our company was started in 2017, Addere Creations, and we are totally passionate about 3D printing, 3D scanning, 3D designing, internships, workshops, products, like our own products which we are working on. Like the best example is 3D printed cast, and then so on. I think many of you have attended our workshops and internships, Addere Creations. Yeah. What we do 3D printing, vacuum casting. Vacuum casting is actually going on in the company, where in 3D printing you will be having only one product printed at a time, but in terms of vacuum casting you will be having a mold to which you will be developing multiple products in a smaller time span. Then coming to product design and development, I think you all are aware about the 3D designing softwares like SolidWorks, CATIA and everything. So all those softwares will be using to develop a product. Then 3D scanning and reverse engineering. 3D scanning is this setup which I'll be demonstrating you in a moment. And then reverse engineering is, for example, a very complex product that cannot be designed in a 3D designing software. So at that time we will be taking the dimensions, or else we will be using this 3D scanning technology to convert that complex product into a printable product. So that is where 3D scanning comes into picture. And then workshops, courses, internships, you all know about this. Products and more. Products are mainly, we have got two products at present. We have got this 3D printed cast. One more is the prosthetic arm. So that we will be having it later, a demonstration. Now, as I have asked from the first at the start itself, like how many people have got fracture. So how we are going to replace the POP cast, which is the practice at present. Actually, the POP cast was started in 1839. From that time, from 1839, that process is going on, and we are again still lagging behind that old age technique itself. We have not come for adaptations in that, for updates in that. Only few updates have come, like the aesthetic part, like to change the color or something to make it more attractive. Not in the functionality part, not much update has come. So that is where we have tried to overcome those limitations of the POP cast and come up with a 3D printed cast. Yeah. This is what the POP cast looks like. It will look very ugly when a person is wearing it. He will not be very confident. He'll be very shy to meet people and everything. Those all aspects. It affects the mental health also of a person. So that is where we have come up with this. I'll slowly take you through how it is done and everything. Now, what are the limitations of POP cast? We'll see it one by one. The application and removal process. Application process of the POP cast, it will take probably around 1 hour because you have to apply it layer by layer. For example, if I can, in short term, if I can say you have to apply one layer of the cast, say the wrap portion, and then after that you have to apply POP, a liquid POP you have to apply it. Leave it for 15-20 minutes so that it should set. and then next layer you should apply. So it will take a lot of time in applying that. So that was the one case. And also in the removal of that POP cast, you will be requiring, we can see the electric saw, because it will be very hard after 3 months, because normally fractures you will be wearing the POP cast for 3 months. So for that period, in order to remove that, you need to take that electric saw, you need to take scissors and everything to cut, because it will not come up manually. You have to take some products to again cut it, so that will be very risky. And also it will be very, the patient will not be free with that process. That is where he'll be scared to get that one. So this was one part. Next one, the bulk weight. Normally these POP casts are applied, at least 4 layers of POP cast are applied in a normal fracture. So that is where probably the weight will go up to 3 kgs, 3 kg of the POP cast. So to support that 3 kgs, we need a neck band also to support that one. So that is where the weight is a big factor, where it will affect the limb also. Even if the healing is there, because of the weight factor, the healing process will be very slow. So that is also the limitation. Next comes to water absorbent. When you want to take a bath, for example, if you want to take bath, you have to cover your POP cast with a plastic. So if it absorbs water, that POP cast has to be replaced, total replacement. There is no substitute in that. So for that, what you have to do, you have to cover it with a plastic. And the best thing what you can do is, you can take shower, you can put your hand like this. It's not possible, right? So that is where this is also a limitation. Next one, blocked airflow. So it will be very tightly wrapped. There is no penetration of air to the skin. The skin will not be totally exposed to the natural air. So that is where it is totally blocked. To that total area, whatever it is blocked, for the next 2 to 3 months, whatever time duration is required for the fracture healing, till that period there will be no exposure to natural air. So this is also a limitation. Next one, plaster source. This, because of the prolonged sweat inside the cast for 2 to 3 months, because of the sweat, there will be some ulcers coming out. In the like after 3 months, when you open the cast, this will be somewhat the condition of the skin. This will relate to it. Anyhow, doctors will be giving the ointments and everything to treat those after that. But the thing is that for 3 months, it will be like that only. It might lead to several diseases, which I'll be showing it in the next slides. One more thing is cracks. As I've said that after applying one layer of cast, one layer of after wrapping one layer, you should apply POP, and it should take 15 to 20 minutes to set. Like that it should be. And after fully it is applied, it should take at least around 3 days to fully set, to fully harden. So in that period, in that 3 months of period, if any crack or something has accumulated in that, then you have to go for total replacement. There is nothing, no substitute, nothing for that. So that first 3 days you have to be very much careful towards your cast. So this is also one more disadvantage. Next one, deep vein thrombosis. This is actually the blood clots. You can see there, because of tight plastering. Doctors will not loosely plaster the cast. They will tightly plaster it so that the limb is restricted, the limb movement is restricted. So for that, because of tight plastering, the blood clots will form, and also because of tight plastering, because of uneven blood circulation through the veins. So this is how the vein will look like. This is how the hand will look like. It will be very much red, and also swelling will be there and a lot of pain. So this is about the deep vein thrombosis. Next one, compartment syndrome. The same thing, because of the uneven blood circulation through the veins, because of tight plastering technique. That is where the blood clots will be formed on the skin. So which will be it is a very life-threatening activity. Next, gangrene. This is also one thing. Here, due to the blood clot formation, this is the next step after blood clot formation, where you will be the tissues at the end, at the extreme end of your hand, the tissue functioning will be very limited at that point. This is a very rare case, but still it is observed in some of the cases where, because of the loose plastering techniques. Next one, Compression neuropathy, the same thing. When you apply the plaster cast too tight, and because of the restricted limb movement for 2 to 3 months, because if you are you will just hold your hand like this for 2 to 3 months, there will be no movement of the hand. That is where this compression neuropathy comes into picture. Next one, dull appearance. When you are wearing the POP cast, the appearance will not be nice. For example, if you want to go to some event, probably some disco or pub, if you want to go at the night, so you cannot go by wearing this, right? Because people will be like staring at you. Okay, he has got fracture, and also you will also be very shy to wear this and go. So that is also one thing. Next thing, skin irritation. Because of the sweat and everything, when the cast is removed, when the POP cast is removed, a lot of skin irritation will be there. It will be itchiness and everything which will be coming. Next one. Mental health. It will obviously affect the mental health, because what I have seen is whenever any person is having the POP cast on his hand, probably they will not be going to colleges and everything, just because to not make sure that you all don't go to college just because you have this cast on your hand. That shyness will come, for sure it will come, because people will be like it will not be a very much eye catching. It will be like they'll be showing you sympathy at that time, so that will not work on that point. Next thing, skin atrophy. Yeah, one more thing, we all know that vitamin D is very much important for us. Morning sunlight is very much important for us. So imagine if till here the POP cast is there, so this total region for 3 months it will lack the vitamin D, because it will be not totally exposed to that to the sun rays. So that is where the skin atrophy comes, which will result in thinning of the skin mass, the epidermal layer which will be present after the skin. So that will become very thin because of no exposure to UV radiations. Next one, going to muscle atrophy, the same thing. Muscle mass will get reduced because of restricted limb movement for a prolonged period. That is also one thing. The next one, prolonged recovery period. That's what, after 3 months, as I have said, normally after 3 months the doctors will remove the POP cast. After that, why they'll remove is because of all these complications which are there. All these complications will give rise to the next resulting diseases. So in order to avoid that, they will be removing it after 3 months only. Even if the limb is not fully healed, they'll remove it, they'll give some ointments, they'll give some tablets for the next healing process. What product we can get into? The 3D printed cast is what the product which we want to do it. So my teammate Prem Sagar will be circulating that product to all of you. You can have a look at it. Yeah. So the next one, how this 3D printed cast is developed. Now coming to the main thing, how this product is developed. It firstly starts with now it firstly starts with 3D scanning. Why we take this scan? In order to personalize the 3D printed cast. In order to personalize the 3D printed cast, because he'll be having his own unique anatomy. The person from person, the hand anatomy will change. So that is where we need to take the 360-degree photos of this hand to generate the 3D model, and then we will be going into production of the 3D printed cast. So this is the first step of developing a 3D printed cast. We will be taking a 3D scan of the hand. In 3D designing, the 3D model what we have got on the from the 3D scan what we have taken. So that 3D model will be converted into a 3D design, where we will be giving all those pores and everything. Why these pores are given? For that better airflow, for better air exposure to the skin, and as well as you can see here we have divided the 3D printed cast into 4 parts. Why? Because for clear application and removal process. While implementing it on the patient's hand, we should be able to apply it slowly. Like it should not be again wrapping and everything, because if we print it fully, then the patient might not be able to insert his hand inside. So we'll be cutting into 4 parts. We will be placing those 4 parts like a puzzle, and then joining all the 4 parts. Next one. That is how all the single parts will be 3D printed separately. That is what. Next one. And now the implementation, and we are happy to say that we have implemented the 3D printed cast on a woman who had a fracture in her leg. That is where we took the 3D scan of her leg from all the sides. We developed a 3D printed cast. You can see here there are few screws and everything. So we have divided the total cast design into 4 parts and then screwed all those designs. Materials used in 3D printed cast. What material we have used? In both these products, we have used PLA material. Why 3D printed cast? Why we should switch from POP cast to a 3D printed cast? What are the advantages of that? We'll see it one by one. First is ease of application and removal, as I have said. We'll just have a comparison between POP cast and this one. In POP cast, the application process was really slow. It should take a lot of time. Now in this 3D printed cast, we should just apply the puzzle, all 4 parts. We should just put the screws and nuts on both the sides. That's it. It will take hardly 5 minutes or 10 minutes to apply the 3D printed cast. And the second one, customization. It will be totally customized from person to person. One person who has got the 3D printed cast printed for his hand, that same 3D printed cast cannot be used by another person because it is totally made out of his hand, out of the hand of first person. So that is where if a 3D printed cast is printed according to my hand specifications, that 3D printed cast cannot be used by another person. That is what customization will come into picture. Next one is water resistant. While taking the bath, while having say some good swimming sessions on the swimming pool and everything, you can actually take this 3D printed cast because of what the problem we were facing in POP cast, wrapping it with plastic and everything. Here that problem will be reduced to a greater extent. Next one is skin friendly. Because of all the skin irritation problems and everything which I have stated before in the POP cast, those all things will be totally eliminated in the 3D printed cast because of the PLA material that is hypoallergenic. It is not allergic. It is not totally hypoallergenic to the skin. Lightweight. If you can see, I said that the POP cast will go up to 3 kgs normally, but if you see that 3D printed cast, it is less than 200 grams in weight. So that is where one more thing it will be added. Here now not required to wear that neck band and everything. You can just take it over and feel free to use it. Next one. Recyclable, as I have said, once the fracture has healed, if the patient wants to donate it back to the company or something, we can again recycle it and use it for the other patient also. It is totally hypoallergenic. The life of PLA material will be very long. And if the life is going to reduce, we can add few more new materials of PLA, make it a blend and then again print it. That is how the 3D printing technology is. Next one is air circulation. Because of the pores which we have provided, in the POP cast, as we can see, there was a blocked airflow because the total skin will be totally blocked from the airflow. Now, because of the introduction of these holes, so the exposure to air will be really very good. One more thing, if we are providing these holes, it will again add to the less weight factor. If we are removing the material from that holes, it will again go for the weight of the material will significantly reduce. That is where it has been done. It is very comfortable to use because only this part will be restricted. The other thumb and everything will be free. So we can use it. We can use mobile phone also. We can scroll everything. We can do it. Next one. Anti-break or anti-crack. As we know that PLA material is very strong. So normal hits if you are having in your home, like some corner hits or something accidentally. So in that case also this cast will not break. That is what the thing. Aesthetics part, that's what it will be very much attractive to look. If you are going in meeting someone, they will be very eager to know what this is actually. They'll be eager to know what you have, how you have got this, how you have made it clear, everything. They'll be eager to know about the product. That is where you will not be feeling shy to meet people at that time. Next one is retained skin moisture. Because of continuous exposure to natural air, so there will be no problems of the deep vein thrombosis, the compartment syndrome complications which I have shown you in POP cast. So that all those problems will be totally reduced here. Next one is faster healing. Because of the use of 3D printed cast, what our research is, because the 3D printed cast is already available in the international markets. the companies in US, the companies in UK have already implemented this 3D printed cast, and what their research is, as compared to the POP cast, if the POP cast takes 3 months to heal a fracture, the 3D printed cast takes half of the time. That is, in 1.5 months, the fracture will be healed, just because of its exciting features, where you will be having great exposure to natural air, where you will be having exposure to UV rays, because all those things, if we are blocking it, if we are not having great exposure to all this natural environment, at that time the healing process will affect. That is where the 3D printed cast can be implemented. Next one is greater accuracy. As I have said that it is customizable from person to person. So if a 3D printed cast is prepared for one person, that same 3D printed cast cannot be worn by another person. And also one more thing, let's not wish for it, but if a person is having a fracture 2 times in his life, that same 3D printed cast he can use it for another time also. Let's not wish for it, but let him not have it once also in his lifetime. Yeah, user satisfaction. That's what I have said, that it adds to the unique appearance. It adds to how attractive it looks. So that is where the user will be satisfied wearing it. Next, how are 3D printed cast picking up worldwide? How it has been going on, how the research work is going on. Now what I have said is only about the hand fracture, and I have said about the leg fracture. So 3D printed casts are going from, it is scalable up to skull fractures also. If there is a problem, if there is a fracture in the skull, if there is some accidental problem in the skull, we can go for a cast which can support that skull fracture. We can go for a cast that can support the hip fracture, that can support the waist fracture, spinal cord fractures. All these kind of fractures can be done. That can be done through 3D scanning. We have to take the 3D scan of the patient's waist, for example, and then we have to develop a 3D printed cast to support that fracture. Next line. Yeah, so that is what the waist fracture, the skull fracture, everything can be done from this. Next one. Now, how can you be a part of this project? All the students who want to be a part of this project, you can actually, and also to the faculty people also, you can guide students to involve with us in this project, because now the prototype model is ready with us. Now the actual thing starts, where we want to process optimize the product, where normally after the 3D scan, in generating the 3D design, it takes almost 1 hour to develop the 3D design out of the 3D scan. What we want to do is, we want to do it in minutes, in 5 minutes, in 10 minutes we want to do it. For that, we need some specialized softwares to do that. So for that specialized softwares, any department student can be a part of this project, because it is totally AI based. Artificial intelligence will come into picture, and also machine learning, if possible, we can add it in this one, so that algorithms can be prepared for faster development of the 3D design out of a 3D scan. And then one more thing, connect us to orthopedic doctors and hospitals. If you have any like reference there to the doctors or something, you can actually connect to us, and then share us your knowledge on fractures. If anyone has some knowledge about fractures, if you have undergone fracture in your lifetime once for all, then you can actually share your knowledge with us. So that is what your contribution, that will be your contribution. Next one. Yeah, so you can ask away any questions required. You all understood the thing, how it is working, everything. Yeah. Any questions if you have in mind? Simple questions, complex questions, anything. Cost comparison, sir, it will be almost equal to the cost of the POP cast. Same thing. One more thing I forgot to mention, in the POP cast, for example, if the POP cast is to be worn for 3 months, after every month the doctor will suggest you to replace the POP cast, because once in a month he'll be testing your fracture healing, like how much it has healed. For that he needs to remove your POP cast, he needs to take the X-ray scan, and then again put a new POP cast in that place. Normally a POP cast will charge you around 3,500 rupees for one setup. So if you are planning for 3 setups, it will go up to 10,000 rupees. 1, 2, 3 setups. But in the 3D printed cast, if you apply it once, and if you want to take the scan, normal X-ray scan, after 1 month, you can remove the 3D printed cast, you can take the scan, wear that 3D printed cast again. That's the thing. That is where the cost cutting can come. it will be less costly than the total cost of a POP cast.
Concentrating on only this product or any other products are coming out, sir?
Any other product on cast itself, sir?
Using this particular device.
3D scanning device. Yeah, it can be done, sir. Now, for example, this one is there, this skull part. So that skull part was actually 3D designed. It cannot be 3D scanned. It cannot be 3D designed. So 3D scanning we have to do all three sides, all 360 degrees we have to do the 3D scanning, and then from that 3D, even that brain cannot be 3D designed. So it is all 3D scanned. 3D scanning can be used in several sectors. We have used that 3D scanning technology in the development of this one. That is what. So if we are going for bone joint and everything, again we have to do the surgery. We have to implement that bone. After 15 days we have to remove it back, because the 15 days time is there for new bone generation. Whenever we have got a fracture, after 15 days a new bone will be generated at that point. So after 15 days we have to remove it back. So again one more surgery after 15 days. So in order to avoid those, we can go with this outer healing process only at that time. Even if we give that provision of movement, the doctor will not allow it, because here there is a fracture. Even if it is possible, the patient cannot move his hand like that one. Yeah. Yes, sir.
The accidents happen.
Okay.
So casualty.
Okay.
So at that time, they cannot go for 3D printing and other things. It may take more time, and also they have to set the bones and other things.
Correct, sir.
So then, how it can be kept?
No, sir. That is what. This is a fracture healing cast. Okay. So once the accident has happened, once the patient is admitted to the hospital, the first. That's what, sir. For the first second round, this cast will come. For the first 14 days, that is called new bone generation days. Actually, in medical terms, it is stated like that. For the first 14 days, the patient will be wearing that POP cast itself, because after the accident, practically speaking, after the accident, the patient cannot wait for one day, for 24 hours, to wait and let the 3D printed cast print and then we can apply. We cannot do that. As and when he has met with an accident, the POP cast should be applied on that one. Say we can apply it only for 2 layers, just for setting it. After that, when this 3D printed cast is printed, we can apply it on that one.
And even it can be used for tennis bone.
Sorry, sir?
So long duration healing.
Yeah. Yes, sir. Mostly what the outside the international companies, they'll be mostly targeting the sports persons for this one. So all the sports persons will be having hairline fractures in their lifetime, some major injury, some minor injury they'll be having while playing and everything. So at that time, I think you might have seen few footballers, very famous footballers, they'll be wearing this 3D printed cast on their hand, and they'll be wearing for just 10-20 days. That's it. Once that fracture is healed, they'll again remove it. That's it.
Okay, sir. What about the process of scanning?
That's what. Yeah, that's what. Today we'll have a live experience. You will be taking your mobile phones. One of your friend will be sitting. One of the other friend will be taking the 3D scan of the hand. So what we will do, we'll collect your data, like normal data, mobile phone and mail IDs. Why mail IDs? Because after once your hand is, we'll be taking the photos of your hand today, and once that scan is generated, we will be sending that file to your mail itself. So you can just have a look like how your hand looks when it is 3D scanned. It's very simple process. I want you people to come and take the scan, not we people taking the scan. One of your friend will be sitting, other person will be taking the scan manually at that time only. It will take around 2 to 3 minutes, maximum 2 to 3 minutes. That's it. Why we want that is, for example, if you want to centralize this product in a hospital, say for example, there the doctor will not be able to come and take the scan. The compounder should be there to take the scan. So what we have aimed at while preparing this product, even the compounder with his 8 megapixel mobile phone camera should be able to take the photos and generate the 3D scan. That was our motto. Not required to take iPhones or iPads to take the 3D scan. Normal 8 megapixel mobile phone camera is also enough to take the 3D scan. That is what our motto was, and we have tested it with normal low to low megapixel camera, that is 8 megapixel. We have tested it. We have got good results in that also. So that is where I want students to get into this workshop and then take 3D scanning, so that they'll be getting the knowledge about 3D scanning, how it works, what all data we have to give it to the software so that it can generate the scan. Because that we need to understand it first. What data the software requires to create the 3D scan, the 3D scan model. That if we come to know, then 3D scan will be generated automatically. There is no stopping it. Yes, sir. Anything else? Questions?
Any questions from the student side? Anybody?
Mobile, there will be one tripod holder. There is one tripod holder there. So that tripod holder will be putting it to this. Your mobile phone will sit on that. We'll take the 3D scans. Normal camera, your mobile phone camera, that's it. Yeah. So we'll take the scans. One by one we'll take it, okay? Yeah. Any other questions?